Hi everyone, it's Coach Fred here today, and today I'm just doing a quick review of the inverse trig functions that you learned about in your class. Today we looked at why when you take the inverse of this function, of these functions, you have a domain restriction. Remember, the functions need to be one-to-one, which means that they have to pass the horizontal line test in order for their inverse to have a function. These functions only pass that test on a certain domain. So that means when we take the inverse function, we actually have to restrict their domains, which means that their outputs are restricted as well. So we're going to specifically look at the range of the functions, okay? So the inverse sine function, we're only going to be able to look at it on a range between negative pi over 2 and pi over 2. And I said that when you're evaluating it, you want to really only look in these two quadrants, and you can't get to the fourth quadrant by going through quadrant 2 and 3, okay? And we discussed that in class. Cosine, we're only going to be looking at its range so that the output's coming in between 0 and pi, and tangent between negative pi over 2, so the same as sine. So those are really related to each other. So let's look at examples of how we would use it. So here we have the inverse sine of negative root 2 over 2. So now I'm going to quickly draw that sine is going to occur between negative pi over 2 and pi over 2. All right, so let's talk about sine, the sine function. So the sine function is negative here and here. So when I'm trying to find its value, I can't be looking at quadrant 3, okay? So first identify the reference angle. The reference angle is pi over 4. That's where sine is equal to root 2 over 2. And it would be negative in the fourth quadrant. But normally we would go around like this to get to the fourth quadrant, but we can't. So now we're going to go this way, which would mean that inverse sine of negative root 2 over 2 would have to be negative pi over 4. All right, arc cosine. Arc cosine is just another way to say inverse cosine. Okay, so inverse cosine. Cosine, when we look at the inverse cosine, we're going to be looking between 0 and pi. So cosine is actually negative in quadrant 2, so we're only going to be looking for the first quadrant angle. So the reference angle for root 3 over 2 would be pi over 6. So in this case, our cosine of root 3 over 2 is pi over 6 because I'm looking for the first quadrant angle. All right, tangent. Again, tangent is similar to sine in that its range is between negative pi over 2 and pi over 2. And we're looking for where tangent is positive, and tangent is negative in the fourth quadrant. So we're again looking for a first quadrant angle. So we need the reference angle. Root 3 over 3 would again be pi over 6. So it would be equal to its reference angle, pi over 6. All right, and you'd be asked, it would be find the exact values if they exist. All right, now let's look at the reciprocal functions, so cosecant, secant, and tangent. Now, a couple things. Sine and cosecant, while they're reciprocal functions, the inverses you have to be really careful with. So sine is related to cosecant, so it is going to have the same range, what we're going to be looking at, but we have to remember, in this case, we have to add something to it. Y cannot equal 0 when we're dealing with cosecant, okay? Secant is going to be related to cosine. So again, the same range, 0 to pi. But in this case, we have to add to it that y can also not equal pi over 2 because it's going to have an undefined value there. And this is where it gets tricky, and we often will forget this because sine and cosine relate to cosecant and secant. We want to believe that cotangent relates to tangent, but when we're talking about the inverse, it doesn't. Yes, it's a reciprocal function to tangent, but its inverse is different, and I want you to think about the graph. The tangent graph looks like this and has asymptotes at pi over 2 and negative pi over 2, whereas the cotangent graph has asymptotes 0 and pi. So when we're thinking about inverse functions, the cotangent graph the range is going to be from 0 to pi. All right, let's look at some examples of these. Now, the process is a little bit trickier. So we're looking for inverse cosecant. So I know that I'm going to be looking for angles between negative pi over 2 and pi over 2. But to evaluate where that's going to happen, I'm actually going to use the sine function. So I really want inverse sine of 3 over 2 root 3. I'd rationalize that, okay, which would give me inverse sine of 3 root 3 over 6, which means root 3 over 2. So I'm asking myself, what's the reference angle? Where is sine equal to root 3 over 2? The reference angle would be pi over 3, okay? All right, but sine is negative in quadrant 4, okay? So we would be looking for the first quadrant angle, which would be pi over 3, okay? So this answer would be pi over 3. All right, let's look at secant. Secant of root 2. All right, so that means I'm going to want the cosine of 1 over root 2, okay, which is root 2 over 2. All right, so cosine happens between 0 and pi. Cosine is actually negative in this quadrant. So when I'm looking at this, I'm going to be looking for the reference angle. So cosine is root 2 over 2 at pi over 4. All right, the last one, the tricky one, right? So if I'm looking for inverse cotangent of negative root 3 over 3, I am going to use the tangent function just to find the value, which would be 3 over root 3, which is 3 root 3 over 3, which is root 3. Okay, so I'm looking for where tangent is equal to root 3, which the reference angle would be pi over 3. Except I want a negative. So let's think about this. If cotangent exists between 0 and pi, and it's cotangent's positive here, it would be negative in quadrant 2, so it would be 2 pi over 3. Okay, so that was a quick review of why we have to be really careful with the inverse functions when we're evaluating them and finding their exact values, okay? And hopefully that was helpful. Have a great day.